Hi everyone, and welcome to our monthly virtual lecture. As a reminder, this lecture is being recorded and it's going to be available in our YouTube channel in the coming days. My name is Carla Gonzalez, and I am pleased to introduce our speaker today, Jean-Philippe Paiement. Today, he will show you how to import data from Geoscience Integrator to Geoscience Analyst, and then conduct meaningful exploratory data analysis using unsupervised learning within the geoapps. All of this in 15 minutes. If you have any questions during the presentation, feel free to type them into the Q&A or raise your hand. Please be aware that JP may wait till the end to answer the questions. All right, the floor is yours, JP.
All right, thank you, Carla. Let's get started here. So it might actually take more than 15 minutes, but we'll try to make it happen. So as you see here, I have Geoscience Analyst open. And what I'll first do is I'll go and connect to the integrator database here. And the goal here would be to go and pull some data from the CMIC footprints Highland Valley copper site. So basically what I'm doing here, I'm just loading up the data from the database using integrator. And you see all of the different objects are here in the menu. So my first goal will be to look at the geochemistry. So what I'll go do is fetch the whole rock data from the database. And if I look here on the panel on the right, this is a bounding box for the geochem data in Geoscience Integrator. And I'll go and uncheck all properties and select only the whole rock geochem data. So the major oxides here. So that's going to take just a few minutes for me to go and select what I want to import. By only importing the suite of major elements here, I'm just making sure that we don't have much overlapping issues between the minor elements or the trace elements and the majors, and that we don't have too many NDVs that would make clustering a bit problematic for that type of work. So this, and just for the sake of it, I'll also include zirconium in my data set. So once this is selected, I can go and run the query. And basically, it's just fetching the data on the server and creating a point set with my properties. So here you have the properties that I've loaded up. So we can look at the different properties here. That's aluminum, we have calcium, chromium, iron, basically just a bunch of elements. So once this is imported in my GA space, I'll go and just save that workspace in my on my disk, right? And this saves the actual point objects to my workspace, and I'll be able to call them using the geoapps. So if I switch over to the geoapps here, this is the menu you would get by starting up the geoapps using the batch file. And I'll go and to the k-mean clustering here. So I'll just run that cell, and it's gonna just produce all of the little tools that I'll need to run the clustering here on my different elements. So here we go. So what I'll do first, I'll go and select the project I want to work with. So basically, I'll just go to my C drive. Should have put it a little bit closer. Make things a little bit easier. Go and change. And this is what we see here. So in my workspace, I have access to points and other data sets. And what I want to run my clustering on is the point data set. So basically by selecting points here, it allows me to go and select different properties from my point data set. So as a quick example here, what we'll do is we'll select elements that we know work well. So we'll go with zirconium, titanium, silica maybe, and potassium. So by selecting that, they've been selected and put it in the in my Python as a data frame, and then we can run different queries. So the first thing we have here on the upper right are different statistical tools. So the first tool would be the crossplots here with different axes. So we can go up to maybe 5 display data set here. So we can choose the x-axis here. So for my x-axis, I'll go and put zirconium. I could log the data if I want, put some threshold, select the min and max also. We'll leave it for that like that for now. And then I'll go and select my y-axis as titanium. So basically, this is what you see here. So that's your classical titanium, the zirconium ratio that's used to identify intrusive suites or volcanic suites. And then I can go 3D by adding a z-axis here. So maybe we'll look at silica here in the z-axis, basically. So what you see here is a plot that's generated through Plotly, which is a library that is pretty interactive. That also allows you to zoom in, spin your data, and look at your scatter plot in 3D. So that's 3-dimension data, but I've imported 4. So what I'll do here is I'll go and modify the size of my points using potassium. So basically, I have the same plot here, but the point size is based on scale by the potassium content here. So this is what you see here. Then I can go and click on statistic. That would give you a table with the statistical distribution analysis for each element that's been selected. I can look at a correlation matrix here. So basically, that's a correlation matrix between what I've selected. I can go and change a color scale if I wanted to. There's different options like that. So we'll go back here. And then you can also display the correlation matrix as a 3D surface. So that's just a little visual tool that might help seeing correlations between different elements. We'll go back to the heat map here. I can also look at the histogram for each of the properties I've selected out of my data point. So here's the histogram for the zirconium, titanium here. So you see there's a nice bimodal distribution in my titanium data. It's the silica data here, and that would be the potassium. So that's one thing I can do. The other thing I can go and do here is actually scale my data. So all of the data would be normalized from 0 to 1 in order to be fit through the clustering app. And the goal here is just to make sure that everything is on the same scale. Just because if you have too much variation in your scales, if you compare, let's say, zirconium here that has a scale from 0 to 300, and if you were to cluster that against something that is like a titanium here that has a scale from 0 to 1.7, zirconium would be overpowering all of the clustering. So what you want to do is scale it from 0 to 1, which is done under the hood here in the geoapps. But what I can also do is say, well, maybe I want to scale it from 0 to 2. So I'll do the same with titanium and zirconium here. And I'll leave silica and potassium scale from 0 to 1. So basically what I'm doing with that is just putting a little bit more importance on the on zirconium and titanium in my clustering process here. So every time I change anything in the geoapps, it's going to update my clusters. So I could actually look at the clusters here right now. But what I'll do here is I'll just make sure it has run the clustering by refreshing. And then I can also go and change the number of clusters I want to produce out of my data set. So that's what you see here. So I'll start with 2, hit refresh. And then I'll just skip the box plot for now, but I'll go to the inertia curve. So that's the inertia curve for the clustering. And that basically helps you find at how many clusters you should actually be looking at for your data set. So usually you'll try to have a number of cluster that matches the inflection point of that on the curve here. There's no clear elbow, but we could say that 8 clusters sort of makes sense, something between 4 and 8. So maybe I'll select 6 clusters for my data here. So basically 6. And you see that the inertia curve is recomputed every time, and there's a point at which you've decided your cluster numbers. So that's it. My data has been clustered. I can now look at how the clusters are against each data point. So again, that's a box plot for clusters. This one is cluster 0 zirconium. So you see that there's actually sort of the clusters there's 6, and then they're increasing in zirconium on sort of 2 scales. If I look at titanium here, these are the clusters for the titanium data. So that's a good way to sort of look at how the clustering is done and how it uses each element. And then I can go back on my crossplot here. And you see that automatically the color has been attributed to my clusters. So what you see here is the same 3D plot I had with the scale on the potassium data, but I can actually see how my clusters are made. So you see that cluster, the green cluster here, relates to probably some low silica, and we'll just put it like that here. That would be high zirconium, and then somewhat low titanium, high titanium values actually if I spin it around. Yeah, so that's what you would see here. So there's different ways. Let's say I want to go back in 2D just to make it a little bit easier to see. I can go and unclick the active button here, and then I would see my 2D scatter plot. So you see that the cluster 0, which is black, is low zirconium to titanium ratios, and then it's mostly clustering the data based on the titanium to zirconium ratio here. So that's that. Let's say I don't like the black color for my lower cluster here. I can go and select cluster 0 and click here, and there's actually a custom color selector that you can do here. So I'll change black to blue. So once that is done, I can look at it in GA. Now that I have the pro version of GA, I can go and click link, the live link here. I can go, you need to reference it to a folder, sort of subfolder in your folder structure, and I'll do the same in GA right now. So in GA, I'll enable the monitoring of the same path. Click OK. And then if I go here and say that would be, let's say, titanium to zirconium, potassium, silica, cluster 6, and click export. If I go into my GA project here and go look at my geochemistry data set, I should have a property that's been created here on my points for the titanium to zirconia clustering that I've done. And then if I just put everything visible here, you'll see your clusters in 3D here. So basically, that's the result from your 6 cluster grouping using your 4 elements here. And then what we can do is maybe go and validate that against some contacts or geological models. So let's say if I go to, again, in the Geoscience Integrator database here, I can go and fetch some contact. Just give me a second. I'll maybe look at the BitSide model here. So that's one thing. You can see that cluster number 3, which is pink, pretty much fits the contact of the intrusive here. So there's different things, and that there's different ways you can look at your results from the GeoApp interpretation you've done in light of different objects that you already have as geological interpretation or whatnot in your geoscience analyst project. So basically, you have here another contact surface, and then you can say, well, sort of fits or it doesn't fit, or how does that relate to other data sets? So that's the beauty of having the live link in GA2 is I can actually put my 2 windows side by side. So to do that, I'll just move the data color to the bottom here, makes it a little bit easier for you guys to see. I'll just reduce that, and I could work side by side on changing the cluster numbers. So if I go here and change the numbers of clusters I'm creating, let's say I'll go to 14 clusters, re-export that here. It's just going to add them up on my point set that I've already have. So again, I should have a new property here. So you see the same property with 14 clusters. So I'll use that to view, make everything viewable. And this is the result of my 14 clustering exercise on the geochem data set. So that's one thing you can do using the GeoApp quite nicely. And then having the live link in GA Pro allows you to directly see the results from whatever work you do in the geoapps into GA and relate that to geological objects or interpretation you already have in your project. So the other thing we could actually do is sort of run the same thing on geophysical data. So I'll just move that back here, make a little bit more room, and then I'll go and fetch some geophysical data set. So let's say you want to look at the mag data. So we'll import the mag data for the area. So that's the mag data over the area that we're looking at. You see sort of the outline of the geological solids. And then we'll go and pull in the gravity data as well. Just make sure that I'm selecting the right one with the filters. So again, here I'll go click, import the data into my workspace. So basically, I could now do the same exercise using the geophysical data set I have. And then really quick, I'll just wait for that to import. Here we go. So now we have a gravity data set, we have a mag data set, and we also have some geological contacts, and we could also have some geochemistry data nicely displayed here against all of the data. So the first thing I'll do is really quickly, I'll just generate a 2D grid on my data to put all of the geophysical properties on the same grid. So basically I'll just go here and say, well, I want to create a grid about that size. We'll keep a grid cell size of 10 and then call that grid, say 2D mag graph. So basically that's been created. So you see now I have a new object that's appeared in my tree structure here. That's named grid 2D mag graph. So I'll go and save my project here to make it available to the geoapps here. And what I'll do is I'll use the geoapps here to actually transfer the properties over from the different grids I have onto my new grid. So to do so, I can use the data interpolation app. So that's the geoapp here. I'll start this one up really quickly. So what I'll do here is I'll just create one grid with all of the data assigned to it, so we can run some clustering and maybe some automated mapping using the geophysical data set we have. So here we go. Drive. Yeah, I should have put it a little bit closer. Virtual lecture. Here we go. So that's a project I want to use. So here you could see that the objects are here. So I have the NRCan mag. I'll use the RTF, and I want to put that on my 2D grid. To do so, I'll just use the nearest point. So once this is done, I'll just say, yeah, I want to open up the link, interpolate. And now you can see the kernel is busy, so it's actually just interpolating the data into the 2D grid. So that takes a little bit longer than the clustering, just because there's more data points, and the resolution of my 2D grid is 10 by 10. So we just have to wait a little bit longer in order to transfer that. So I'm currently transferring the mag over to my 2D grid. So basically, if I were to, once it's done, actually done running right now. So you see now my 2D grid has property for the mag data. So what I'll do is I'll do the same thing with the gravity data set as well. So let's hear the gravity. Oh, that's my 2D grid. Sorry, I'll go and select the gravity data here. So you see I'll have all my filters. So I'll go and select the forward base bouquet, put that on my grid, click interpolate. And again, it's putting the data. So you see here the RTF has been interpolated onto my 2D grid. And now I'm running the same process with the Bouguer anomaly from the gravity data set. So it takes a little bit longer again. There we go. So that's done. So now if I look at my geoscience analyst project, I should have both properties available for display. So you see here, that's the Ford Bouguer anomaly that's been interpolated into my 2D grid, and then you see the RTF here. So basically, if I would want to create a geophysical sort of response map here really quickly in 2D, I could use that that data to run a clustering exercise really quickly. So again, I'll go back into my clustering here, geoapp. I'll go and select. I actually have to rerun it to make the 2D grid available. And then what we'll do is we'll try to make domains that are using both the mag and gravity data in order to sort of create a pseudo map of the surface signature of those. So here I should now change the project over again to my project here. Select my project, and now I should now have the 2D grid available. I'll select my two properties. And then since there's more than a certain number of points, you'll see that the downsampling option here has been used. So it's downsampling the data to under 5,000 points to run the clustering, and it's going to put it back once this is done. So if I just go and look at the data here on my crossplot, I have the gravity here, and then I should have, oops, here we go. So that is done. Then again, I'll enable the live link. So it's thinking. And then we can call that grav mag clusters. Let's say we do, oops, not 2, but 4 clusters to start with. So I'll go here and say I want to create 4 clusters. And you see it's running right now. So let's run. I can go and look maybe at the box plot for so that's the gravity box plot, that's the mag, and then if I export these clusters, I would be able to look at them on my grid. So now it's exporting. You see that the little circle is black. It's done exporting. And then if I open my geoscience analyst project, I'll be able to look at the results here. So again, I haven't changed the black color to anything else, but you see there's different domains that have been created on my data. So you see that's the different the different litho domains generated from the mag and gravity signature. This one takes a little bit longer than the geochemistry, and that's just due to the high number of points that I'm actually trying to look at. But if I put that here again, we can do this sort of same exercise, and I can go and increase the number of clusters. Now here, click, I have 1, 2, 3, 4, 5, 6, 7, 8, 9 clusters. So maybe say 9, export here, and it's working, and it's going to export it through the live link to GA for me to be able to look at it. So it's really easy to go back and sort of iterate on your clustering process to see the results in 3D or against other data sets in order to validate your interpretation. So we see now that it's been exported. So now I have new properties on new property on my 2D grid that relates to the 9 clusters from my map. And then you can sort of see what's starting to appear here. So I have my map. I could have I could display the points on there and look at how my geochemistry, there's a bit too much stuff here, so we'll remove the geophysical. Yeah, here we go. So I can look at how my geochemical clusters relate to the geophysical signature at surface of different rocks, and then start really doing some 3D integrated interpretation and analysis of all of my data sets. So that's about it. That's done. And that's how you can use the geoapps in conjunction with the live link to do some exploratory data analysis in GA and the geoapps of your geoscience. Thank you very much. I don't know if there's any questions.
Well, that was cool. Thanks, JP. And thank you to everyone who joined today. So yeah, if anyone that's in the lecture has any question, we'll give you a bit of time to type any questions you may have or raise your hand. If you do have any questions in the future, anything that comes up later, please don't hesitate to email us at support@mirageoscience.com. And we will also look forward to seeing you next month when Valerie Laflèche will be showing how to access a multitude of open license mineral exploration data from the Seismic Footprints Research Project. So we have one question. And JP, that question is, how does it handle no data values? Oh, you're muted, JP. Sorry.
Hey, all right, that's easier. So for now, what it does is there's a certain value that's been assigned through GA for no data values. So they're actually just being filtered out. So the issue with that is if you transfer your data from geoscience analyst to your geoapp, any row in your data frame that's created that has NDV is basically going to be filtered out, because you can't run the clustering if there's no data. So that's how it manages the no data values for now.
Okay, great. So then we will see you next month, and thank you everyone for coming.